Hi guys, this is John Anderson with Ragdoll Animation Studios. You can find all of our tutorials and our professional work at www.ragdollanimation.com. Today I want to discuss creating water simulation in 3ds Max using only the tools native to 3ds Max instead of any third-party plugins. For the purposes of this tutorial, we will focus on the water simulation itself and not on object buoyancy. I plan to discuss how we can achieve object buoyancy simulation in a future tutorial. In order to achieve the desired effect, we will be using the flex and point cache modifiers as well as particle flow. We will also briefly cover the path constraint, although we won't delve too deeply into how that works. I have gone ahead and set up our sandbox scene with a water plane and a pool type object for visual purposes, and a very simple boat object. The water plane will be the focus of most of our work. I've set the length and width to 145 inches by 145 inches and the segments to 100 by 100. To get started, what we're going to do is we're going to hit F3 if you haven't already so we can see through the objects. And then what we're going to do is go into the Create panel, select Line. We're just going to give our boat a path to follow. Okay. And then we're going to go ahead and go into our spline vertices. And we're going to make sure everything is set to Bezier. We want to make sure that there are no turns that are too crazy. So we want a fairly smooth path. Okay. The next thing we're going to do is select the boat. We'll go into our motion panel, select position, click assign controller, and then we'll select path constraint. Hit OK. And then we're going to add our path. So click add path, and then you'll move your mouse cursor over and select the spline. Now notice that the boat is not aligned to the path. We're going to go ahead over here and select follow, and then you can notice that it's aligned sideways. We want to change the axis to Y, and if it's backward as it is here, we'll flip the axis. So now our boat should follow the path correctly. I will select the path, go into perspective mode, and I'm just going to give myself a better view of the sandbox area, and I'm going to move the boat up until it's just sitting in the water like that. Now one thing that I can see already is the boat, as it's moving along the path, is moving in a very static way. We actually want this boat to bank into the turns. So I'm going to go back into my motion panel, and then we can see that right here there's a checkbox for bank. We're going to go ahead and check that, and you can see now it's banking considerably. Definitely more than what we're looking for. So I'm going to change my bank amount to 0.15 and try it again. That looks a little better. Okay. So the next thing I want to do is go back into my top view. I'm going to grab my water plane right here, and I'm going to go into my modify panel. I'll click the drop down list for my modifiers, and I'll select flex. Now there are a bunch of settings in the flex modifier, and we'll cover some of those. This initial setting, flex, it's set to 1.0. This is the amount of flex and bend in the object in response to movement or external forces. The strength sets the overall spring amount. Alright, what ends up happening is based on all of our settings here, The modifier will establish springs within the object that we're not going to be able to see, but those are going to control how the object deforms based on the deflectors and the forces that are moving through it. Okay. Our next setting is sway. Sway is basically sets the time the object will come back to its resting state. And then we have our chase springs. These are going to be the springs that will help the object deform during the simulation. Weights are essentially allows the vertices to be weighted and applies the flex modifier accordingly. All right, so we can vary the weights based on our other settings in the modifier. Our solver type is set by default to Euler. There are 3 solver types: Euler, midpoint, and Runge-Kutta 4. Euler is usually pretty good by default. However, if our object has very flexible deformation, then Euler can sometimes not be as stable as the other 2. So I think for now we're going to go ahead and stay with Euler, and then if we have a problem, if we're getting some unexpected results, we can try another solver type like Runge-Kutta 4. Samples. This is how many times per frame the simulation is calculated. We're going to go ahead and stay with 5 for now. Okay. This button right here, create simple soft body. Once we have all of our settings established, then we'll create simple soft body, and that will establish all of the springs in the modifier. Once you've created a simple soft body, you can go ahead and continue to make changes, and they'll update automatically. Okay, stretch determines how much the object edges can elongate or stretch. Stiffness determines how rigid the object is. Vertex weights, if you check absolute weight, which we will for our simulation, this sets all the vertices at the same weight. Forces allows you to assign space warps to our flex modifier. The space warps that are supported by this modifier are displace, drag, gravity, motor, P-bomb, push, vortex, and wind. We could assign deflectors to our simulation. All of the deflectors native to 3ds Max are supported. Okay. So to begin, we're going to set our flex. We're going to try 2.0. Okay. And for a water simulation, strength and sway, usually if they're set low, that works best for water simulations. So I'm going to do 0.05 and then 0.05. I'm going to go ahead and leave Euler, and I'll leave my samples at 5. I'm going to go down to stretch and stiffness, and I'll try 10 for my stretch. And I'm going to try to start with 3.5 for my stiffness. Okay. Now I'm going to go ahead up to my deflectors, and I want to have a deflector in my simulation. Basically, I want this boat to act as a deflector that deforms the water as it's moving through it. So I'll go to my Create panel, I'll move over to Space Warps, and then I will click on the drop-down list and select Deflectors. We're going to select U-Omniflect, and we're just going to drag out a deflector in the scene. Now what U-Omniflect does is it allows you to assign an object as your deflector. So we're going to click Pick Object, and we're going to select our boat object. Okay. Now one thing I want to do is I want to make sure all of my objects are named. So the boat object is named boat. The water plane is named water plane. And I have named the pool containment box. I'm going to change that and just call that pool object. Okay. Now that I've set my settings, my initial settings, I'm also going to check absolute weight, and I'm going to set the absolute weight to 0.1. Okay. And now that I have all of my initial settings, I also need to go into my deflector and add that deflector. So I'll click add and I'll select the deflector. Okay. So we're just going to create simple soft body. We're going to push this button and it's going to go ahead and create all the springs in the simulation. I'm going to go back into my perspective view, and if I play, scrub through the simulation, we're going to see that the water will start to deform with the object. You can see the edges and the geometry actually moving now in relation to the boat. Okay. Looks good so far. Now I want to be able to see this play in real time. We can do a couple things. We can go ahead and scrub through just by hitting the arrow right here, or we can hit the period button on our keyboard, and that will allow us to go ahead and scrub through. The other thing we can do if we want to see this in real time, which we're going to go ahead and do because I want to see how it's playing out, is we can add a point cache modifier to the simulation. So above flex, I will click the drop down. It's frozen up just a little bit, so I'll just give it a second, see if it resolves. Okay. Ooh, come on. Work with me. Simulation can chug your system sometimes, so that's why we use the point cache modifier. So I'll click point cache, and then under cache file, I'll click new, and I'm just going to assign it a name, wake.xml. There are two different settings, two different file types. One is PC2, one is .xml. .xml is what we're going to use for now. PC2 would be if you want to bring this into Unity 3D in conjunction with a Modifiers plugin. You could use .pc2, but we'll use .xml for now. Click save, and I already have a file existing, so you probably won't get this, but if you do, just click yes, and then we're just going to go ahead and record. Now you want to make sure your start and end frames are correct for your simulation length, and then hit record. We'll notice that the simulation will probably freeze up in the viewport. If it does, that's fine. It's still happening in the background. So what I'm going to do now is I'm going to go ahead and pause the video until my simulation finishes. It probably will take about 1 or 2 minutes. Okay guys, so the point cache has finished computing, and it is saved out, but you notice that we still have the flex modifier turned on. We're going to go ahead and turn that off. We could have, before we recorded the point cache, we could have turned on this button right here, disable modifiers below, and that would automatically disable all the modifiers below the point cache. Okay, so now if we go back to our frame 0, we can see that our simulation is going to play smoothly in real time. Now you'll notice that down here the simulation stops. Alright, let me go ahead and get out of the object and play this again so that you can see it without any edge frames. So it stops right there, and the reason for that is our deflector actually turns off at 100 by default at frame 100. So what we're going to do is go back into our deflector, and we're going to hit time on 300, and this will be at, for whatever length simulation you need. Now I'm going to go back to frame 0, go back into my water. I'm going to turn off point cache and turn my flex modifier back on. Okay. Now I will go ahead and turn on my point cache modifier, and I will unload my simulation, my file, and then I'm going to go down and make sure that 0 to 300 is checked on, is my start and end times, and then I'm going to re-record this simulation. And again, you'll notice that the simulation, the viewport freezes up. So I'm going to go ahead and pause the video, and we'll come back when it's completed. Okay, so our point cache is completed again. I've gone ahead and turned off the flex modifier. And now if I play through this animation, it should play through pretty smoothly. So I'll click play, and we get some pretty believable water simulation in here. And you can go ahead, if you're not getting great water simulation with your project, then you can go ahead and modify some of the settings in the flex modifier. Those settings, the ones that are really going to affect your simulation are going to be this number right here, these three numbers actually. So for water, you want this to be, this basically will be how significant the wake effect is, and these will be the ones that really control the springs that will achieve a nice water simulation. Okay, so again, I'll play through. Let's get another good look at this. We're getting a nice wake effect. You notice that right here it seems to settle down a little bit, and then as it turns into the next turn, we get some more water motion. So that all looks pretty good. Alright, so the next thing I want to do is I want to I'm getting a nice wake effect, but I want to start to get some of that foam that you would see falling behind the boat. So what I'll do is I will just isolate my boat here, and then I'm going to spin around, and I'm going to find the back of that boat. Alright, and we can do a couple things. I'm just going to go ahead and grab these faces, and I will go into my local up here, coordinates, and then I'm going to hold down shift, and I'm going to drag these out a little bit, and I will give these a new object name, and we'll call these emitter. So basically what I want is for this will be linked to our particle system, and these will emit the particles. Alright, so I will link this to the boat, and then I will right click on the emitter, go to object properties. I'm going to turn off receive shadows and cast shadows, turn off renderable, and hit OK. And I'm just going to give this a different color so that I can find it pretty easily. Okay, and now I'm going to go ahead and create a Pea Flow by going into our create panel, and then I will go back to our geometry. I'll use the drop down, and I'll select particle systems, and I'll just drag out a PF source. Okay, I'll just drag it up so that I can see it at any time. Now I'm going to go into my Pea Flow by going to the modify panel, opening up particle view, and then I'm going to delete my position icon, and I'm going to select position object and drag that up in place of the position icon. And I'm going to select my emitter object, and that's going to be that emitter that we created down there. Now if we notice, when we play this through, we're going to get our particles emitting from the boat. We want them to emit for the entire 300 frames, so I will go into my berth, and I'll set my emit stop at 300. Okay, and we'll just leave it at 200 for now. The next thing I want to do is end isolate, and what I want to do is I'm I want these particles to actually lock onto the water as it's moving through. So what I'll do is I will also turn on speed by, I'll get rid of this speed right here, and I'll turn on speed by icon. Where is it? Speed by surface. And I'll add that emitter as the surface speed. And then I'll set this down low, I don't know, 10. And we can try it again. We can play it again and see how that's looking. That looks pretty good. Let's set that even a little lower. Let's go 2. That looks pretty good. Okay, the next thing we want to do is we want to lock it onto the water plane. So I will go into my my particle view, and I'll look for lock bond, and I'll drag this up just under shape. Okay, and then I'm going to go ahead and select my water plane here to lock onto. We can play this, and you can see that it's locking onto the water plane, but it's not locking onto the surface so much as just the object itself. So I want to lock it to the surface. And then I want to select animated surface, and this is going to chug my system quite a bit, so you got to be careful with this. It's not too bad yet, but it can chug the system, especially when you go in reverse. Okay, and now I want to actually see some geometry in here instead of these little tick marks. So I'm going to go to my display. Actually, let's go to shape first, and we're going to select a sphere for our shape. We can choose different shapes, but for now I think that's going to work fine. And for our display, we're going to choose geometry. We want to be able to see it. We'll go back into our shape and we'll choose our size, and we'll set the size down much lower. Not that low. I want to be able to still see it. And just keep adjusting this until you have something that looks pretty good. I'm going to go ahead and do 0.25 and see how that looks. That's not too bad. For now anyway. Okay, let's actually do a 0.35. A little bit bigger. Alright. We can see that those particles are now moving with the water, and it looks pretty good. I like the way that looks. I don't think there's enough of them, so we can go ahead and do a couple things with that. I also want them to kind of move around a little more. So what I'll do is I will choose random walk, and I'll drag this up, I guess just above speed by surface. And what this will do is make those move, walk around a little bit. So we can adjust the diameter. That's actually, sorry, that's the icon. Try the speed. I'm going to turn off my lock bond so that I get a better view, so this plays a little more in real time. So you can see those are moving around a lot. I think what I'm going to do is adjust the random walk and place this underneath the lock bond and see if we can get some a little better look. I want these particles to move around a little bit on the water surface. I'll set this speed down to, I don't know, 2. And try that again. That's not bad. They're moving around a little bit. That's kind of what I want. And then try that. I want to go in and see if they're walking vertically a lot, and they are kind of moving vertically. So let's turn on lock bond and see what that does. So they're moving off the water, and I don't really want that to happen. So I'm going to move this back up. Alright. Let's, I think that works fine. Alright, so that looks pretty good. There are some other settings in the lock bond that we could do. We could do restrict to surface. If we find that it's they're sitting too far above the water, and they are sitting a little bit above the water, so we could move them down a little more. We could also hit snap to surface. I think maybe we might want to do that because I am noticing that some of these are much further above the water than I want. So I'm going to click snap to surface and see if they'll snap down. That's a little better. And play that through and see. I like that. I still want these though. I want them to walk more. And I'm not really getting that walking motion that I'm looking for. And it probably is because they're sitting below the lock bond, and because these are locked on. So let me see if I go into my lock bond settings. I'm going to drag this back down underneath and see if we can make these things move around a little more. So we're starting to get some, but it's really jittery. I don't like how jittery that is. Let's try and adjust our noise. Let's do this at like 50. See if we can adjust that jitter. Not loving that noise. Alright, so I think what's happening is that the lock bond and the random walk are conflicting. So I'm just going to go ahead and get rid of that random walk. I think that for the most part, I think this will be fine. It looks pretty good. The only thing I'm noticing is I don't want this trail as long as it is. So we're going to do a couple other things. I'm going to have the particles be a little larger initially, and then I want them to kind of get smaller. So I'll go into my scale. I'll drag a scale in, and then I will set the scale to relative successive. And then let's try adjusting these numbers and seeing what we get. Yo, way too high. Way too high. Alright, click out of that. I've lost my objects. It's just too big. All right, let's try this. I'm going to do this at 0.1. See if we can find our simulation again. It was kind of crazy. All right, so let's try, I don't know, 0.5 and see what that does. It's a lot of back and forth, a lot of trial and error. All right, I don't see the particles, so we'll just keep trying. Let's try 50. See what we get there. Nada. All right, let's try 80. All right, I can start to see the particles. And now I see the whole thing. All right. So we're getting what we're looking for. It's starting out larger and then kind of trailing off and getting smaller. So let's change our initial shape to like 0.7 for size. And then let's go into our scale and try this at like 98 and see what that looks like. Alright, so that looks good. It is trailing off. I like that. The initial size might be too much, but let's just go ahead and leave that for now. And then I want to delete these as they get too old. So I will bring in a delete, stick that under scale, and for the delete, what I'm going to do is set that for by particle age, and we'll give that a lifespan of, say, 60 is deleting them right about there. Let's try 150 for half of our simulation. So that's giving us quite a bit. I'm going to bring this back down to, say, 110. Try that again. And we'll try our variation at, I don't know, 40. A little bit of trial and error, a little bit of back and forth, but I think that that's looking pretty good so far. Now, in our point cache modifier, in our particle flow modifier, we can also cache the particles. So I'm going to drag a cache up into my particle view, and then I'm going to go ahead and cache by updating. Just select update. And we can see that those particles are now locked to the surface. Our cache is good. So now we should be able to play this in real time and have it look pretty decent. And we can set the particles much higher so we can get more foam. And the other thing we can do is we can actually create more particle flows so that we actually have particle flows attached to the outside of this boat so that they're giving this they're kind of aligned with the wake a little more. But I think that we'll try one more. We'll see if we can make the just give a lot more particles in the simulation and see how that will look. Right now we're at 200. Let's try 1500. Let's go kind of crazy. It's gonna take a little bit to update, and we might find that now these particles are a little too much. They're a little too large, so let's just try 0.5. Make them a little bit smaller. Alright. And if we found that we're having, it's too consistent, then we could try to go in and change some of these. I could try to get random walk to work. We could try to move, get the particles to jitter a little more. But I think that this is fine for now. I'm going to go ahead and update that cache. Okay. And then I just want to test it by playing it. I think that that looks pretty good. So the trick now is to, um, the foam that's trailing behind the boat would obviously have more of a whitish material on it, and the water would obviously have a water material. Now we could create that water material with a standard material by using a ray trace, refraction, and reflective maps, or we could go ahead into our mental ray, and give it kind of one of the set materials, like pool water or whatever, or river water. Okay, so that's everything for today. I think this looks pretty good. We're getting some pretty realistic water simulation. We have set up a foam trail behind our boat, and I think it's looking pretty good. So we could definitely expand on this. We could add more foam particles. We could have a larger water plane that isn't contained within the pool, and give it much more of you know, a larger area, and have this look really good. But I think this looks pretty good for now. So with that said, I think we're going to end this tutorial, and hopefully we will come back shortly, in the next week or so, and we'll talk about buoyancy and see if we can get this boat to react with the water, as well as the water reacting with the boat. So again, this is John Anderson with Ragdoll Animation Studios. If you want to check out more of our work, more of our tutorials, you can go to www.ragdollanimation.com, and check us out. Awesome. Thank you very much. Bye.